Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the smallest positive root of the equation x cubed minus 5x plus 1 is equal to 0 using the fixed point method. Solution. So when you are given an equation to find the smallest positive root in a numerical analysis question like this, for the method we're going to use here is fixed point method. You have to find the interval in which the smallest positive root lies. Normally in some questions they give you the interval, but in this question the interval was not specified, so we have to find it. The root of an equation, when you substitute it into the original equation, it gives you 0. So now if you find two numbers that one will give you negative, the other will give you positive, then the root definitely will lie within the interval of negative and positive, because 0 is in between negative and positive. So now we'll say f of x is equals to this function x cubed minus 5x plus 1. This is the function. So now we're going to substitute numbers into this function to find the interval. So first we'll substitute 0, so it will be function of 0 is equals to, it will be 0 cubed minus 5 times 0 plus 1. So this 1 equals to 1. Then we'll substitute 1 also. This is negative 3. So you can see that when we substitute 0, we will get 1, and when we substitute 1, we will get negative 3. That means the root lies in the interval of 0 and 1. Because when we substitute the root inside this equation, it's supposed to give us 0. But most of the times in numerical analysis, it's hard for you to find a root. When you solve it using numerical analysis, it's hard for you to find a root that will give you 0 on the dot. Some usually 0.00000, maybe 1, or 0.0000578, like that. But the general root of an equation, if you substitute it in that equation, it will give you 0. So that's how we know that the root of this equation must lie between the interval of 0 to 1. Maybe 0.5 or 0 point something, or 0.2 or 0.3, but the root lies between 0 and 1. So then we can say that the positive root lies in the interval the interval 0 and 1. So now, using fixed point method, you have to rearrange this equation in such a way that we can do the iteration. There are some ways that you put this equation that the iteration will not converge. So you have to know the form that you put it that to converge. So like, for instance now, we know that in this equation, x cubed minus 5x plus 1 is equal to 0. So let's make this x the subject of the formula. So it becomes 5x is equal to x cubed plus 1. So x will be equal to what? S cubed plus 1 over 5. You see? So you see, this is the form of our iteration, and the iteration method in fixed point method is given by xn plus 1 is equal to the function of x n, where n is equal to 0, 1, 2, going to infinity. So now we have to add n plus 1 here and n here. So this function now becomes xn plus 1 is equal to xn cubed plus 1 over 5, where n is equal to 0, 1, 2. So you see, this is our iteration function now. So this is the iteration function we are going to use. in doing the iterations. You can also decide to make x cube the subject of the formula. So it will be 1, it will be 5x minus 1. Then you find the cube root of both sides. If you do it like that, the iteration will not converge. So in the fixed point method, when you make x the subject of the formula, in some ways, like this one, when you make x the subject of the formula, sometimes it will not convert. So you have to express that equation another way and start the iteration from beginning. Like this one, when we do it, it will converge. But when we make x cubed the subject of the formula, it will not converge. So this kind of in method of fixed point is usually tricky. This kind of method is this kind of method is the type of method that you do the iteration over and over again until you find a subject of formula that converges the iteration. So let's do this. So let's start the iteration. The first iteration, when n is equal to 0, first iteration, when n is equal to 0. So we'll substitute it here. If we substitute in this equation, this one becomes 0 plus 1, which is 1. Then this is x0 cube plus 1 over 5. So now we'll substitute. So we have to select our x0. Some people usually confuse this part. They think if they choose a particular value for x0, that's what will make them get the answer. But no, any value you select as your x0, the iteration, if it's method of fixed point method and the equation is correct, the way you express the equation, the method will converge. The iteration will converge to give you the correct answer. So let's use x0 is equals to 0. If you use x0 is equals to 1, you still get the same answer. But you will still get the same final answer, but your workings along the line will be different from the person that takes the other one. So now our value x0, let me write it. x0 is equals to 0. So this becomes what? 0 cubed plus 1 over 5. Then 1 over 5 is what? Is 0 0.2. 0.2000. So this is the value for x1. So now the second iteration, n is equals to 1. So now it will be, when we substitute it in this equation, it will be 1 plus 1, which is 2, is equals to x1 cube plus 1 over 5. So this will become what? This will be 0.2 cube plus 1 over 5. Zero point two oh one six. 0.2016 is x2. Then n is equals to 2. We will be doing this iteration until the value keeps repeating itself. To be x3 is equals to what? x2 cube plus 1 over 5. This becomes what? 0.2016 cube over 5 plus 1. 2016. Here is 0.2016 again. So it has repeated itself. 0.2016. We can do it one more time to be sure. x4 will be equals to x3 cube plus 1 over 5. 0.2016 cube plus 1 over 5. Okay, so it will still give us the same thing because you see. So it will still give us 0.2016. So you can see that this iteration has converged to 0.2016, and that means this is our final answer. Since x2 is equals to x3 is equals to x4. Normally when you get the same answer twice, you can stop the iteration. But today I just want to move further. But normally when you get an answer twice, that's so you can stop the iteration. So this, we got it 3 times. Even though we continue, we'll still be getting 0.2016. So now you can test the equation. This equation, x cubed minus, so we'll put this 0.2016 cube into the original equation. This equation, 0.2016 cube minus 5, it should give us 0 or something close to 0 to show that it's the root of this equation. It's the smallest positive root. Some questions ask you to find the smallest negative root, or this is the smallest positive root. But this question asks for smallest positive root. So this is the smallest positive root, 0.2016. Then plus 1. You see? You can see that when you move this decimal place, 1, 2, 3, 4, it will give you 0.0002. You can see 0.0002. So it's almost tending to 0. So it's still correct, because if you approximate it to 4 decimal points, to give you 3 zeros after the decimal point. So it's still almost equal to 0. So this is the root of this equation, the approximate root, not really exactly, but it's approximate. So this is the approximate root of this equation, and the root is 0.2016. So you can write that therefore the smallest positive root of the equation is 0.2016. So this is the smallest positive root of the equation. So if we could have expressed this equation, maybe we could have used this x cube as our subject formula, and then we find x after we find the cube root of both sides. This iteration would not have converged to this. It would have given you random answers. It will never converge. The equation will never converge. In fact, the equation will even give you values that are outside this interval. Like for instance now, If you take this to the other side and make it and find the cube root of both sides, you get 5x minus 1, then cube root of 3. Now this will be x when we use x cube as the subject of the formula. Now let's put 0 and see to see our first iteration. You see -1. It's not even in the interval. You see negative interval is not even in this interval. You see, it should only give us answers between 0 to 1. That's the value, that's the answer this is supposed to give us. It's supposed to give us answers between 0 to 1, and it's giving us -1. You see, if you also use 1 as the initial approximation now, you see it's giving us 1.5. 1.58. So, and between the root of this equation should be between 0 and 1. From the first iteration, it already diverged to another answer. So you can see that this one it will never converge. So when you use a particular subject or formula and you start getting this kind of answers, you have to cancel that one and do the next one and use the other value of x as your subject or formula. So this one converges, but this one will never converge. So that's it. So this is how you find the root of an equation using fixed point method. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.